This is Bill Levinson, and this is part 3 of the slideshow that goes with LMS 2012. In the previous slideshow, we looked at the concept of the standard as being the servant and not the master. Now we're going to go on to the third learning objective, which is the concept of critical to lean versus critical to quality characteristics. Remember that a lean management system is a synergistic combination of technological, behavioral, and organizational principles, and that requires buy-in and engagement from all members of the workforce. We're going to start with critical to lean characteristics, a concept that needs to be understood by everybody in the workforce and indeed everybody in the supply chain. What's the difference between critical to quality and critical to lean? Critical to quality characteristics are those that can be measured in some way, and they have to be in or out of specification. They have to be inside the specification limits in order to meet the customer needs. There's also, of course, intangible critical to quality characteristics that determine whether or not it meets the customer's needs. There are, on the other hand, critical to lean characteristics, and they determine whether the product is as inexpensive as it should be. Critical to quality characteristics are inherent to the product or service itself. They're measurable on individual work pieces, and they're either in or out of specification. In the case of a service, it might not be as tangible. For example, is a restaurant meal good or is it bad? That's often up to the perception of the person who eats it, although there are some objective standards as to whether the food is good, bad, overcooked, undercooked, or so on. But in any case, you're talking about an individual item or an individual service that can be looked at usually by the customer, and the customer decides whether or not it meets requirements. Critical to lean, on the other hand, is inherent to the process that delivers the product or the service, and it's generally not measurable on any individual workpiece. For example, using the restaurant meal as an analogy, the food can be outstanding, but depending on how the kitchen is laid out, how the work is arranged in the kitchen, it can be time-consuming to prepare or less time-consuming to prepare if the kitchen is particularly efficient. So critical to lean is generally not measurable on any individual item or service. It is, however, measurable in terms of cost and often on-time delivery, which brings us to the important point that waste is usually asymptomatic. Asymptomatic means, of course, there are no symptoms. When you have a critical to quality nonconformance, you get a lot of pain symptoms in the form of rework, scrap, or customer complaints, which drives an organizational response in terms of closed-loop corrective action to remove the cause of the nonconformance and make sure it doesn't happen again. Waste is, however, asymptomatic when quality is good. You can have 100% quality, which means nobody perceives a need to do anything, but the process can nonetheless be extremely wasteful. We mentioned bricklaying earlier. Frank Gilbreth cited bricklaying operations in which masons laid 125 bricks per worker per hour, and the job design required the masons to bend over to pick up each brick. Now, if you think about that for a moment, it requires a person to raise and lower his entire upper body weight to pick up a brick that weighs 5 pounds or so. So that's enormously wasteful of human strength, human energy, probably not very good for people's backs either. But Gilbreth's book on motion study includes a photograph of people laying bricks. The bricks are indeed on the ground where the masons have to bend over and pick them up. Now, bricklaying is one of the world's oldest trades, and it's quite likely that people did figure out ways to do the job more efficiently, but due to lack of written records, the improvements were lost over the centuries and had to be relearned. Gilbreth finally put them down in writing, and that was part of the science of motion efficiency. The Gilbreth non-stooping scaffold delivered the bricks at waist level, which is where the work should ideally be delivered, and it allowed masons to lay 350 bricks per worker per hour. Now, in both cases, the quality of the walls may have been identical, which is the critical to quality characteristic, but the cost of the walls differed enormously, as did the wages of the workers involved. Obviously, if you can lay 350 bricks an hour, you should get paid more than if you lay 125 bricks per hour, assuming the work is of equal quality. And that's one of the foundations of lean manufacturing. By making the job more efficient, you allow your customers to pay lower prices, but you can pay your workers higher wages and also make more profits. The lesson then is it's important to distinguish critical to quality from critical to lean. Poor quality causes symptoms in the form of the organizational equivalent of pain, which drives closed-loop corrective action to remove the cause of the poor quality. If the quality is good, however, there's usually not much incentive for change unless people know what to look for. This leads to the need for simple but comprehensive lean key performance indicators. Simple means easily understood by everybody in the organization and everybody in the supply chain. Comprehensive means covers every conceivable form of waste. Henry Ford, back in 1922, identified exactly 3 kinds of waste, namely time, materials, and energy. Every form of waste wastes time, materials, energy, or a combination of those 3 things. It's useful for analytical purposes to expand time to waste of the time of things, namely the product or the service, which is measurable in cycle time, and waste of the time of people in terms, for example, of motion inefficiency. Waste of the time of things is equal to all cycle time in which value is not actually being added to the work. Now, when is value being added to the work? It's added, and this has been pointed out by, for example, Masaki Imai, only when the tool is in contact with the work. Imai uses a term or a phrase called the value-adding bang. That's the moment at which value is added to the job. If you think of a stamping press, when it closes, transforms the work, that's when value is added. Everything else, the time necessary to put the work into the tool, remove it from the tool, transport it, does not add value. The book by Standard and Davis, which is cited in the book's bibliography, adds the analogy of a golf game, say an 18-hole golf game, which takes about 4 hours, and they calculated that the club head is in contact with the ball for about 1.8 seconds out of a 4-hour golf game. In other words, the tool is in contact with the work, and the lesson was that in many factories, the manufacturing cycle efficiency isn't much better. When you look at the time in which the work is actually being performed and the time that the work spends in the factory, it really isn't much better. So elimination of waste of the time of things reduces your cycle time, reduces inventory, increases throughput, also allows you to make to order instead of make to forecast, which is a valuable competitive advantage. Here's the analogy from Standard and Davis. The title of the book is Running Today's Factory, a Proven Strategy for Lean Manufacturing. This is the actual quote from Masaki Imai's book, Gemba Kaizen, which is available from McGraw-Hill, and this is what he had to say about the value-adding bang. Here are examples of non-value-adding cycle time. Delay, any type of delay, including storage. If you look at parts in the warehouse, that's delay right there. Transportation is viewed as a necessary evil. Obviously, the work has to get from one place to another. On the other hand, a container ship is essentially a floating warehouse. Inspection and testing, you have to do them, but they don't add value. Handling and setup assist value, but don't add value. Again, they're necessary to the job, but they don't actually add value. Frederick Winslow Taylor's book on shop management, incidentally, had a timesheet from actually before 1911. I think it was from where he worked back in the 19th century, where it described steps involved in setting up work for machining. And on one side, they talked about things like setting the work up, clamping the work, unclamping it, and so on. The other side depicted activities in which the tool was actually in contact with the work. So even back then, there was a recognized difference between setting the work up and actually processing the work. Today, of course, we have single-minute exchange of die, the idea being to reduce handling and setup time. It's extremely important to identify waste of the time of things, because once it's identified, you realize there's a problem, and then you can conduct a project to remove it. When you reduce your cycle time, you have less inventory. That's according to Little's law, which relates inventory, throughput, and cycle time. Shorter cycle time means you have less inventory tying up capital and possibly serving as a hiding place for defects. Also, if you get the cycle time short enough, you can make to order instead of making to forecast, which means you don't have the risk of inventory or finished goods waiting in the hope that somebody will buy them. Waste of the time of things includes waste of the time of assets for which value-adding work is available, and I stress for which value-adding work is available, because making inventory to keep assets busy is a dysfunctional performance measurement that creates far more problems than it solves. An example would be the capacity constraining resource under Goldratt's theory of constraints. Time lost at the constraint is lost forever, so you definitely don't want to waste that particular asset's time. Also consider, for example, a passenger aircraft that earns money only when it's in the air, when it's on the ground being serviced, loading, unloading, and so on. It's not earning money, so anything you do to reduce the turnaround time allows the asset to earn more money. As a matter of fact, United Airways was sending some people to a school for pit crews, race car pit crews, because the race car pit crews know how to turn a vehicle around, change the tires, refuel it in the space of perhaps 10 seconds or so, and get the car back on the road, because every second you lose is time lost in the race. So they were actually learning similar techniques because they recognized that the asset earns money only when it's working. Waste of the time of people includes any kind of motion efficiency. Henry Ford said that no job design should require anybody to take more than one step in any direction or bend over at the waist. Also, poor ergonomics and human factors also qualify as motion inefficiency. Waste of materials, any purchased material that includes consumables, for example, like metal cutting fluid or solvents for paints and so on, that does not become part of the finished product, is a form of waste, and if it's a pollutant, it also becomes an ISO 14001 environmental aspect. This is why ISO 14001 is consistent with LMS 2012. If you do what's in LMS 2012, you're addressing all of your possible environmental aspects and therefore supporting ISO 14001. As one example, Shigeo Shingo had a client who was getting complaints about paint solvents getting into the local water table, and it turned out they were spraying these fountain pens, painting the pen caps in a spray booth. And Shingo took one look at that operation and he said, is your objective to paint the air or the pen caps? What he meant was most of the paint was missing the pen caps, and then the solvents would become environmental waste. And also, of course, they were throwing the paint away, so they redesigned the process to have nozzles direct the paint directly onto the paint caps, which solved their environmental problem without having to install any pollution controls, by the way, because the paint didn't miss the caps in the first place, also reduced the amount of paint that they had to buy. So they made a lot of money by doing this as well. Waste of energy is the last key performance indicator, and this is consistent, by the way, with ISO 50001, the Energy Management System standard. And the next step is to deploy these lean KPIs through an improvement cycle, namely IMAIS, isolate, measure, assess, improve, and standardize, which is the fourth learning objective on the list.